cover
Good morning, y'all. My name is Emily Dietrich, and I'm the marketing intern at Eagle Fire for the summer. I'd like to welcome each of you here today, as well as those joining us from Charlotte, Charleston, and other remote locations. After the presentation, we are going to have time for you to be able to meet with each other if you haven't been able to do so already, and also we'll have time to ask questions to Adam, as well as any of our Eagle Fire staff here today. Thank you for taking the time out of your day to come. We really appreciate you coming here today to listen to Adam Hilton about nitrogen generation systems. If you could, please silence your smartphones. We do understand that the need may arise for you to take a call, and if you need to, if you could just do that outside, that'd be great. Also, if each location could mute their microphones to avoid any feedback, that would be appreciated. Before we begin, I'd like to go over a few logistics for the day. Lunch will be distributed around noon, but please continue with conversation with Adam and within each other. After the presentation, we will ask that you fill out a survey, and a completed survey is going to be your ticket into a raffle prize drawing. So with your completed survey, if you could place that up front, or you can just hand it to me and we'll get that in for you. There are sodas and waters in the fridge, so help yourself throughout the presentation. And also the restrooms are located just through this back door and to the right. Now we do have 3 fire exits today. There are 2 located in the rear, 1 located in the front. However, there are no wing exits in our cabin today. Now I would like to introduce our speaker. Engineered Corrosion Solutions is a corrosion engineering firm specializing in helping clients understand and manage risks associated with leaking fire sprinkler systems. Since 2003, ECS has pioneered the research of corrosion in fire sprinkler systems. This research has led ECS to develop and introduce corrosion control equipment and methods such as nitrogen inerting. Corrosion in fire sprinkler systems leads to water damage, plugging problems, reduced hydraulic performance, and reduced service life. The risks associated with corrosion in fire sprinkler systems include life safety risk, property risk, and business continuity risk. It is ECS's commitment to define and understand the root causes of corrosion in fire sprinkler systems and to produce products and services that can bring about a reduction in these risks. I am pleased to introduce Adam Hilton, the Project Engineering Manager from Engineered Corrosion Solutions, to speak with us today. Please join me in welcoming Adam.
Thank you. So thank you again for giving us a little bit of your time today. As Emily said, we're going to talk about corrosion specific to fire protection systems. A little background on myself. I have an electrical engineering degree, and people say, well, how do you do, why are you in fire protection? I started out right out of college doing alarm and detection, special hazard systems. I moved into suppression, and there was an opening and opportunity with a young fledgling company, FPS CMI at the time, now known as Engineered Corrosion Solutions. And I saw what they were doing. I thought it was a wonderful area to begin to work in. So I jumped over to ECS, and I've been over there for about 5 years now. Today we're going to talk about corrosion. We're going to go over some science stuff at the beginning. It's going to be very high level. Anyone has any questions pertaining to anything I talk about on any of these slides during the presentation, please don't hesitate to ask. Some of the best conversations happen when someone says, well, I don't believe you, or I don't think what you said is necessarily right. If you have specific questions to maybe one of your facilities, we kind of save those to maybe during lunchtime. I'd be more than happy to get into those in a greater detail. So with that said, is that on? The on button. Now you're going to believe everything I say, right? Anyway, so we first talk about, first question I get asked a lot, how common is corrosion? Or someone comes up and says, you know, I've got this really weird issue in one of my buildings. We opened up for a 5-year inspection, and this nasty, sludgy, slimy, orange-black stuff came out. We think we have an issue. What's going on? The answer is corrosion is common. Corrosion is everywhere. All we're doing in a fire sprinkler system, if you think about it, we're taking raw steel, we're putting water in it, and we're trapping oxygen in it. It's no different than if you take a piece of metal and set it out in the parking lot and just let it sit there, it's going to rust. That same reaction is happening on the inside of the pipe in every single fire sprinkler system. So one of the things about our industry, in the fire protection industry, is we just consider corrosion normal and unavoidable. We say leaks are going to happen eventually. We think eventually we're going to have to replace some pipe, and if the building makes it long enough without a major renovation, we might just have to replace the whole system because the leaks get so bad, they cause business continuity risk, they cause life safety issues, that we just go ahead and rip the whole thing out. So we consider it just normal to have corrosion in our industry. And the reason our industry feels that way is because we've never really had anyone look at corrosion. And that's kind of unique in an industry that deals with pipe and water. You go to the oil and gas industry and they literally have buildings full of engineers that all they do is look at corrosion, the causes of corrosion, compatibility issues, and ways to extend the life cycle of their infrastructure. And when we really didn't do that until about late 90s, early 2000s. As an industry, we started getting interested in what was causing these leaks and how could we extend the useful life of our systems, or how could we stop the leaks from happening. So like going down that vein, the current practice involves we just repair a leak. If we have a leak, we repair it. If we have a leak, we repair it until we get to a point, and there's a slide later on, we call this the pain threshold. And what that means is eventually you're going to spend so much money repairing leaks and on service calls that you might say, I can't afford to spend $50,000 a year on this building. I'm just going to make a capital budget improvement to the building. We're going to bite the bullet. We're going to rip the whole thing out. We're going to put a whole new system in. But what we're going to go over today is that's really not necessary. You don't have to do that. We say this to some people, insanity is continuing to do the same thing and expecting different results. And I could give you an example of that. We did a large study for a large big box home retail goods store. And they had an outside garden center where it was required to be protected by a dry system, a galvanized dry system. And they came to us and they said, we're spending a lot of money on leaks and replacing these systems. And so we started asking questions. We said, well, what does your typical system look like? A Schedule 10 galvanized dry system, about 1,000 gallons of capacity. And they said, we found we're replacing them about every 10 years. So we said, if you give us some of your data, we'll look at it and we'll kind of explore the issue for you. What we found when we looked at it is they were right. If you looked at all their facilities over the entire United States, about every 10 years they were replacing these systems to the tune of $100,000 to $150,000 per system, depending on where they were in the country. The really interesting thing that we found from their data was in year 5 to year 10, they spent as much money replacing compressors, service calls, leaks, and all of that service geared specifically towards that dry system as they did in year 10 when they replaced it. So they were effectively buying each system 2 times, putting the same thing in, and we even had enough data that we could go back and look at systems that had been replaced twice. So that's a perfect example of if you don't treat the root cause of what's happening, if you don't treat the root cause of corrosion, you're just going to keep repeating it. You're going to keep doing the same thing over and over and spending the money over and over. So now we're going to jump into a little bit of chemistry. This is all very high level stuff. If you have any questions, like I said, just jump in. But it helps to understand what corrosion is when you understand what steel is. When we make steel, we take raw iron ore, which is iron oxides, which is essentially a form of rust. And we take it to the mill, we put a lot of energy into it. And when we put a lot of energy into it, we add electrons to it and we form steel. So steel is, if you imagine it, a high energy state. It's like taking a bowling ball and trying to hold it like this. You want to put the bowling ball down. Nature's the same way. That steel, that iron, wants to give up those electrons and revert back to iron oxide. So that's why, given any opportunity where there's liquid water present and oxygen present, your steel will corrode and it will revert back to essentially iron ore, iron oxides. So now that we kind of understand a little bit of that, let's talk about what kind of myth, we call them industry myths. They're just really misunderstandings or misappropriations of knowledge. But it's things that some people have come to take as this given fact in regards to corrosion and fire sprinkler systems. So how many people have heard of MIC? I mean, have you guys? Yeah, a lot of people. Does anyone know what it stands for? Microbiologically influenced corrosion. So what it means is there's actually bacteria in the pipe that is metabolizing the iron, actually eating the iron and creating metal loss and through the wall failures. MIC is a very real thing. You can find it in a lot of environments. In our environment, in the fire sprinkler industry, because of the type of materials we use, the temperatures we operate at, and the pressures we operate at, MIC really isn't a concern for us. Now, I know a lot of people are going to say, well, I just paid to have my water tested, and they came back and it said I have highly contaminated with MIC. So I'm here to tell you that all that test is doing is seeing if we can culture bacteria out of wherever you sample it. I could wipe this podium now, I could culture bacteria. That doesn't mean that this podium has MIC. It doesn't mean that MIC is doing anything bad to this podium. It just means that we could grow bacteria off of that surface. So when you get a water sample back, or when you get a MIC test back, or someone tells you you have MIC, you might probe a little further into that and say, okay, well, we've cultured the bacteria, but show me that the MIC is actually creating problems. And we'll go into it later into the presentation. We'll talk about how can we tell if a leak is caused by MIC, or if a leak is caused by oxygen or acid or anything like that. We'll show you how to determine that. Number two is bad water. So I can't tell you how many people call me up and they say, Adam, I've got a bunch of leaks. I've got a system infected with MIC, and it's because I have bad water. I'm in Arizona. We have horrible water out here. It's really, once again, at the pressures, the temperatures we operate at, water chemistry is not a significant influencer. And then when you compile on top of that, probably 98% of fire protection systems are fed with drinking water. Just outside your building, we split off. There's a domestic service, there's a fire service, and we're putting the same water into the fire sprinkler system as coming out of your sink, your faucet. Anywhere around the country, the pH of that water is going to be 8 to 8.5. So it's fairly neutral. It's been treated chemically. There's not a lot of stuff in it. So it's really not contributing to the corrosion at all. 3 is bad pipe. So a lot of people, when I go work out in the field and working with a fitter that's been in the industry for 15, 20, 25 years, he'll tell me, back when we got all our pipe from Pittsburgh, everything was great. We never had any problems. These systems never leaked. You could put them in, forget about it, and they're fine. They said, as soon as we started going overseas for our pipe, we started having issues. It's because they don't make the pipe appropriately. Well, NFPA 13 actually addresses this, and NFPA 13 is a standard for fire sprinkler system installation. And there's 3 standards, 3 ASTM standards that tell you, depending on what type of pipe you're using, what type of specifications it has to meet. One of the services that we offer is pipe testing. And in fact, we actually get called upon about 5 to 10 times a year to be professional